You just describe a feature in plain English, and a complete block of back-end logic self-populates in seconds. Modern AI coding assistants execute the mechanical work of writing syntax flawlessly and continuously. By early 2026, over 85% of developers use these tools every single day. According to data from GitHub, artificial intelligence now directly authors roughly 27% of all committed code. This chart maps that massive rise in automation against the current tech job market. Notice the discrepancy. While AI adoption has climbed steadily, software engineering job postings haven't dropped. They have spiked by up to 30% year over year at major tech firms. This presents a distinct paradox. If artificial intelligence is writing syntax up to 55% faster than a human, why are the world's most efficient companies aggressively expanding their engineering teams? The answer starts by examining a practice known as vibe coding. This is the modern workflow where you describe your software requirements conversationally, and an AI agent translates that intent into functional output. Vibe coding has proven highly effective for building 0-to-1 prototypes. The speed creates a temptation to skip the complexities of explicit syntax, especially as entry-level roles focused on repetitive tasks begin to shrink. The software engineer's role is shifting. The physical act of typing out boilerplate is disappearing, leaving the developer to focus on the logical orchestration that previously lived behind the keystrokes. Removing the manual typing process removes the friction that traditionally slows developers down. Without that friction, an engineer's underlying comprehension of computer science, or their lack of it, is immediately exposed at scale. AI tools operate as cognitive offloaders. When you let the machine do the thinking, your system knowledge decays. And in a live production environment, deep foundational knowledge is the only barrier preventing a catastrophic system failure. We can measure exactly how this cognitive decay happens. In early 2026, Anthropic ran a randomized controlled trial testing 52 junior developers. Their task was to learn and implement a new Python library. This graph tracks completion times. The AI-assisted group outpaced the control group. But on the mastery test, the AI group scored 17% lower, 2 letter grades behind. Their comprehension collapsed specifically in debugging accuracy and identifying edge cases. By entirely offloading the generation phase to artificial intelligence, these developers crippled their ability to maintain the system. They could build it fast, but they could not take responsibility for it. This creates a stark boundary between a functional AI prototype and a reliable production-grade system operating at scale. Prototypes tolerate loose logic. Production environments do not. When deployed across large, complex codebases, AI routinely fails to maintain long-term architectural consistency. It creates solutions that work locally, but break the broader system logic. This introduces severe security risks. Studies show that up to 45% of AI-generated code introduces vulnerabilities, particularly SQL injections and authentication bypass flaws. The cost of this technical debt is delayed, but massive. There are real-world instances where development teams have been forced to abandon heavily AI-authored microservices months after deployment, simply because the human developers can no longer untangle the hallucinated logic. AI can efficiently brute force the first 80% of a software feature, but the final 20%, ensuring that code is secure, performant, and maintainable, demands rigorous, manual human oversight.
This reality disproves the prevailing narrative that programming languages are dying out in favor of natural language prompting. Modern programming languages act as precision constraint mechanisms. They provide the guardrails necessary to prevent AI models from generating nonsensical or hallucinated logic. Compared to plain JavaScript, binding an AI by the strict type definitions of TypeScript causes significantly fewer logical errors. The explicit syntax forces the machine to comply with your architecture. This is exactly why systems languages like Rust and Go are surging in popularity. Their strict compiler rules, combined with rapid AI generation, yield code that is both fast to produce and deeply safe to execute. Mastering syntax now involves selecting the specific linguistic boundaries required to safely govern AI behavior. Because the machine handles the boilerplate, the modern developer must transition their focus to high-level system design, complex data structures, and concurrency. Immediate visual code validation is now mandatory. An engineer must be able to glance at AI-generated output and instantly recognize if that logic will trigger in deadlock at 10,000 requests per second. This requires a new meta skill, AI orchestration. This encompasses advanced prompt engineering, meticulously managing context windows, and chaining multiple AI agents together. Industry analysis from firms like Boston Consulting Group points to another rising requirement: deep domain expertise. Combining intricate knowledge of verticals like fintech or healthcare with seamless AI integration makes an engineer exceptionally valuable. The highest leverage engineer is the one who can take a highly ambiguous business problem, map it to a secure production deployment, and consistently use AI purely as an accelerator to get there. To transition into an AI-augmented engineer without degrading your foundational skills, you need a structured workflow. This is a pragmatic 30-day adaptation protocol. For weeks 1 and 2, devote your time to one strictly typed language. Use AI to write the actual code, but force yourself to provide a verbal or documented explanation for every single line it generates. If you can't explain it, you can't commit it. In week 3, build a complete microsystem, such as a rate-limited API. Rely entirely on AI for the syntax, but maintain absolute unyielding personal ownership over the system architecture, the security boundaries, and the observability pipeline. By week 4, focus on mastering orchestration tooling. Configure custom rules in your IDE, learn how to manage agent context modes, and explicitly separate your casual vibe coding exploration phase from your rigorous production review phase. Executing this daily workflow actively prevents the cognitive offloading that ruins junior developers, while still letting you harness the immense speed advantages of modern tooling. So, to answer the core question, yes, developers absolutely must continue learning programming languages in 2026. The current market shows a clear displacement. Developers who pair AI with deep fundamentals are moving into higher leverage roles, while those who skip the basics find themselves hitting hard walls in complexity and scale. The career equation for this era is clear: deep computer science fundamentals combined with expert AI orchestration equals an irreplaceable software engineer. Artificial intelligence is a tool for leverage, not a substitute for logic. Mastering the machine, rather than surrendering your intellectual autonomy to it, remains the single highest leverage career path in technology.